Hi everyone, today our discussions will be inverse trigonometric functions. This will be the first class for inverse trigonometric functions. And before we start today's class, the basic concept on inverse functions. The questions in front of us is that for our functions to exist inverse, what is the preconditions? So is there any conditions required of functions to be invertible? Let us see that. Corresponding to every bijective. Bijective means 1, 1 and on to function f from a to b, there exists unique function bijective. Remember these 2 points, very important, that for corresponding to every bijective function, that is 1, 1 on to, say f is 1, 1 and on to functions, there exists another unique functions. Okay, remember this, another unique function also to be bijective, g from b to a, such that g y equal to x. Now here g is said to be the inverse of f and is denoted by f inverse. So therefore most important is that if f to be invertible, that if the inverse of f exists, it has to be 1, 1 and on 2. And only because of that we are discussing this point before we start inverse trigonometric functions. Now remember that if fx is equal to y and f is bijective, then we can write x is equal to f inverse y. And most important relations, what is that? F inverse, not f. What is f inverse? F inverse is the inverse of f. F inverse, not f, equal to x. So how to explain this? F inverse, not fx. By the definition of composition functions, f inverse fx you can write, if you remove the not, you can put a bracket. Now f inverse, now what is fx? Fx is equal to fx. Fx is equal to y, right? Fx is equal to y, right? And what is f inverse y? F inverse y. F inverse means what is f inverse? F inverse is nothing but g, that means g of y. Now what is g of y? G of y is x. So therefore f inverse, not fx, equal to x. Okay, similarly you can explain f not f inverse y equal to y. Fine? Okay, next. We are going to rediscuss the graph of sine and cos functions. There is a reason, because it may be in your mind like why you have to discuss about the sine cosine graph. Yes, it's a very important point. We know that these functions are periodic functions, okay, and periodic functions. Now the question in front of us that these periodic functions are 1, 1 or not. Okay, we know that periodic functions are many one functions always. You can see that sine 0 equal to 0 here. Then all an integral multiple of pi. You will see that sine pi is 0, sine 2 pi 0. Okay, we have learned that sine and pi is 0. That means for integral multiple of pi, sine and pi is 0. And for all the pre-images, sine functions are connected to 0. So obviously sine is in many one functions. Similarly, you can define cos. You can explain cos functions. So here these 2 functions, what we have discussed, both are many one functions. That means neither sine is bijective nor cos is bijective. Now that's why we are discussing this point, that since sine and cos for the domain R, we know the domain of sine and cos both is R. Therefore, with the domain R, sine and cos are not bijective functions. Now we are going to discuss how both functions, sine and cos, okay, can be made bijectives. Now let us go for the next point. Okay. First, if fx equal to sine x, and we know that for sine x the domain is R and the range is -1 to 1. Now in case we have already just discussed that if we take the domain as R, the sine function is not bijective. It's not 1, 1, it's many one functions. Now what we're going to do is, we'll restrict the domain of sine. if we restrict the domain of sine to minus pi by 2 to pi by 2, this one. If we restrict the domain of sine to minus pi by 2 to plus pi by 2, then sine functions become 1, 1. With the range minus 1 to 1, it becomes 1, 1 and on 2. And hence, sine function will be bijectives, and we will think of finding inverse of sine functions. Okay, now remember one thing, the sine function, if you restrict to not only minus pi by 2 to pi by 2, actually restricting sine function to any of these intervals, like minus 3 pi by 2 to minus pi by 2, minus pi by 2 to plus pi by 2, pi by 2 to 3 pi by 2, etc. The sine function becomes bijectives. Okay, now remember one thing, that corresponding to such one interval, we get a branch in the curve. Okay, now really corresponding to this particular interval, that is minus pi by 2 to pi by 2, the branch that is obtained is called principal value branch. Okay, remember similarly we can explain the cos functions. Now for cos functions, the domain is R and the range is minus 1 to 1. So with this domain we know that cos function is not bijective. Now again for cos function, if we restrict the domain of R to 0 to pi, if we restrict the domain of cos function to 0 to pi, the cos function becomes bijective. Then we can define the inverse cos functions. Actually, the way we explained about the interval of sine, similarly, this cos function also becomes bijective to many of the interval of this type. Like we can define this cos function with this interval, say 0 to pi, then pi to 2 pi, then 2 pi to 3 pi, etc. And corresponding to one such interval, we will get a branch again in cos functions. But corresponding to this particular interval, that is this particular interval, we get a branch, and this branch for cos is said to be the principal value branch. Now, most important table for discussions is coming up. Okay, next. This is the table with the help of which you can remember the domain and range, that is principal value branch of the 6 trigonometric functions. And remember, for all the 6 inverse trigonometric functions, domain will be the range of these functions. Now, for sine, we remember for sine the domain is R and okay, the range is minus 1 to 1. Now this minus 1 to 1, which is the range of sine, will be the domain now, right? Similarly, for cos, it's R to minus 1 to 1. Now this minus 1 to 1, the range will be now the domain. Similarly, we can explain the other domains. Okay. Now already have discussed about the sine. Now what will be the range? That is principal value branch for sine. It's minus pi by 2 to plus pi by 2. For cos, 0 to pi. And for cosec inverse, minus pi by 2 to pi by 2, excluding 0. Similarly, for sec inverse, 0 to pi, excluding pi by 2. And for tan, minus pi by 2, tan inverse, minus pi by 2 to pi by 2. And for cot inverse, 0 to pi. This is the most important table, and you should remember this table. Next. Okay, these are the graphs of two functions. Today we are going to discuss the graph of these two functions, and in the next video we are going to discuss the other graph. Now this is the graph. We are representing this graph here. Both the graphs are there. That is sine graph as well as sine inverse x graph. Here also cos graph and cos inverse graphs. So this graph representing sine inverse x. And remember, both the graphs are shown on principal value branch. Okay, and we know that for sine inverse x, the principal value branch is from minus pi by 2 to plus pi by 2. So this graph is the graph of sine inverse x, and this portions is the principal value branch for sine inverse x. Similarly, for cos inverse x, the principal value branch is this. This is the graph on the principal value branch, and we know that the range of the principal value branch for cos inverse x is 0 to pi. Okay, now we have seen that this is the cos graph, right? Similarly, okay, this is the sine graph. And what is this equation? This is y is equal to x, and this is also y is equal to x. And we have seen both the graphs, okay, along this particular line, y is equal to x, behaving like a mirror image. Like for both, for sine also, you have seen that for y is equal to x, okay, y is equal to x is behaving like a mirror. We are getting a mirror image along this particular line. Okay. Next, some very important point. Okay. If no branch is mentioned of an inverse trigonometric function, say branch is not mentioned, because we have learned for each interval we are getting a branch. If the branch is not mentioned, then we always will understand, okay, the principal value branch. Next, the value of an inverse trigonometric functions. The value of an inverse trigonometric, very important, value of an inverse trigonometric function which lies in the range of principal value branch. Which lies in the range of principal value branch is called as principal value. Okay. Now, graph of inverse trigonometric functions can be obtained by interchanging the coordinate axis. That means you want to draw the graph of sine inverse x from sine x, interchanging x and y axis, you can actually draw the graph of sine inverse x as well as the other trigonometric graph, inverse trigonometric graph, okay, or by taking its image in the mirror y is equal to x, what we have shown just now. Okay. Next, today we'll be discussing some questions on principal value. Okay. Let us take some very simple questions on principal value. Okay. What are the questions we'll discuss today? Question 1. Find principal value of the following functions. Find the principal value of the following functions. Remember, these questions you are going to solve along with me. Okay, let's start. Question 1. Sine inverse minus 1 by 2. How to solve this? How to find the principal value of sine inverse minus half? Let sine inverse minus half equal to y, right? So what's the next step? Sine y equal to minus half. Now let minus be there. Now half this 1 by 2 right in terms of sine. That is sine pi by 6, right? Now how to write minus sign? How to simplify this sign? That's minus sine. This minus can be written as sine minus pi by 6, because we know that sine minus theta equal to minus sine theta. Done? Okay. Now, most important, whether this minus pi by 6 lies in the range of principal value branch. Okay. Now, what is the range of principal value branch for sine inverse? Okay. We have just now shown that range of principal value branch for sine inverse x is minus pi by 2 to plus pi by 2. So definitely minus pi by 6 lies between minus pi by 2 to plus pi by 2. Just write the range of principal value, okay, range of principal value branch of sine inverse is minus pi by 2 to pi by 2. You need to only check. Why we are mentioning this? We need to check whether minus pi by 6 is lying here or not. It's lying, therefore definitely you can write the range of principal value branch of sine inverse is minus pi by 2 to pi by 2. Therefore, principal value you can write, therefore principal value is equal to minus pi by 6. Done. Okay, next we'll solve the another question on the same concept. Okay, then next question, 2 cosec inverse 2. Okay, let's start. Let cosec inverse 2 equal to y. This implies cosec y equal to 2. Now write 2 in terms of cosec. This will be cosec. Okay, 2 in terms of, it will be cosec pi by 6. Now what is the range of principal value branch for cosec inverse? We know range of principal value, range of principal value branch of cosec inverse is. Do you remember what is the range of principal value branch of cosec inverse? It's, yes, it's minus pi by 2 to pi by 2, excluding of course 0. Now we have to check pi by 6. Yes, definitely pi by 6 lying between minus pi by 2 to pi by 2. Hence principal value of cosec inverse 2 is equal to pi by 6. Done? Okay, let's move to the next question. Okay, what is the next questions? That tan inverse minus root 3. Next, tan inverse minus root 3. Let y equal to tan inverse minus root 3. Tan inverse minus root 3. This implies tan y equal to minus root 3 equal to minus 10 pi by 3. What's the next step? Tan y, this minus 10 pi by 3 can be written as 10 minus pi by 3. Now what is the range of principal value branch for tan inverse? The range for the principal value branch for tan inverse is minus pi by 2 to pi by 2. Okay, and since range of principal value of tan inverse is minus pi by 2 to pi by 2. Therefore, y, that is principal value. Okay, the principal value is minus pi by 3. Done? Okay, we'll solve one more question similar to this, then we'll move to some other type of questions. Okay, these are all simple questions, and okay, we're not going to spend much time on this. Then we'll take questions where 2-3 functions will be mixed together. Okay, last, that is 4, question number 4, cos inverse minus half. Cos inverse minus half. Okay, let y equal to cos inverse minus half. This implies cos y equal to minus half. Done? The let minus be there. Now half, how can you write in terms of cos? It will be cos pi by 3. Now like the other questions, can minus cos pi by 3 be written as cos minus pi by 3? Let us see that. Okay, cos minus theta is equal to cos theta. So you can't write in that way. That means you cannot insert it minus sign in pi by 3. So for that you need to change the quadrant, that is cos pi minus pi by 3. Why? Because we know that cos pi minus theta equal to minus cos theta. So we have to remove minus sign, so we need to change by this cos pi minus theta. So it will be cos pi minus pi by 3. Cos pi minus pi by 3 means cos 2 pi by 3. Right? Cos 2 pi by 3. Now most important is that what is the range of principal value branch? The range of principal value branch of cos inverse is 0 to pi. We know that 0 to pi. So definitely 2 pi by 3 lies between 0 to pi, and therefore principal value, that is y equal to 2 pi by 3. Done? Right. Okay. So we'll move to our next type of questions where we have more than one function together, and we need to find the principal value directly. Okay. We are going to solve few questions of that type today. Next, evaluate the following. Okay. This is question 2 for today's discussions. Evaluate the following. Okay, number 1. What is question 1? What is 10 inverse 1 plus cos inverse minus half, then plus sine inverse minus 1 by 2. How to solve this? Okay, remember this, we need to find a principal value of each of the functions. It's given evaluate, that they are not mentioning any branch, so we obviously understand that we need to calculate this on the principal value branch. 10 inverse 1, pi by 4. Now cos inverse minus half, just now we have done. Okay, what is that? That is 2 pi by 3. 2 pi by 3. That is sine inverse minus half. That also done. Sine inverse minus pi minus half. That is minus pi by 6. Done. Is equal to, okay, is 12, 3 pi, okay, 8 pi, and minus 2 pi. This one, it's obviously pi by 4, and cos inverse minus half, the previous questions, and similarly we have done sine inverse minus half also. So finally, 8 plus 3, 11 minus 2, 9 pi by 12, okay, 3 pi by 4. Done. This is the question where we have done the principal value, evaluating the value directly. In case you are not able to make this, get the value directly, obviously you can find this value separately and you can write the answer. Next. Okay, what is the next question? Next question is this question 2. Okay, sine inverse minus 1 by 2 plus 2 cos inverse minus root 3 by 2. 2 cos inverse minus root 3 by 2. How to solve these questions? Just now we have done sine inverse minus half, it's minus what? Pi by 6. Done. Plus 2. Now we need to calculate cos inverse minus root 3 by 2. Right? Now for root 3 by 2, cos what? Cos 30 degree. Pi by 6. And since minus is there, okay, we need to use this formula. Cos pi minus theta equal to minus cos theta. And here theta for this case is pi by 6. Therefore, it will be, this value will be the principal value for cos inverse minus root 3 by 2 will be 5, that is pi minus pi by 6. That is 5 pi by 6. Done? Okay, this one we have done directly, and I hope all of you have done this. 10 pi by 6 is equal to 9 pi by 6, and if you cancel by 3, that is 3 pi by 2. Okay. In fact, just want to find out that why cos inverse minus root 3 by 2 is 5 pi by 6. The step for this one is this, that cos inverse minus root 3 by 2, you assume as y separately, then cos y, okay, cos y is equal to minus root 3 by 2. Now minus root 3 by 2 means it's what? Cos pi by 6, then can be written as cos pi minus pi by 6 and cos 5 pi by 6. But most important is this 5 pi by 6. You have to check whether this 5 pi by 6, though we have written 5 pi by 6, whether 5 pi by 6 is in the range of cos inverse x or not. Okay, that obviously the range for the principal value branch for cos inverse is 0 to pi, and definitely 5 pi by 6 lies between 0 to pi, and therefore the principal value for cos inverse minus root 3 by 2 is 5 pi by 6, and finally this is the answers. And finally we are going to solve the last question of today's class, and next class we'll discuss about the graph as well as the most important the properties that of trigonometric function, inverse trigonometric function, where most of the questions are solved on properties, and you have got many more properties. And basically today's class was the introductory classes consisting of some basic concept, graph, as well as a principal value and principal value branch. Okay, that the last question for today's discussion is this: tan inverse root 3 minus sec inverse minus 2. So what we have to do is we have to evaluate this value tan inverse root 3. Let us try to write the answer for it, that is principal value of tan inverse root 3. Tan inverse root 3, the principal value is 5 by 3. Okay, now for sec inverse minus 2. For sec inverse minus 2, let sec inverse minus 2 equal to y, sec y equal to minus 2. This is not root, this is minus 2. This can be written as minus. Okay, sec pi by 3. Sec pi by 3. So how to remove the minus sign? So you have to change the quadrant. That is sec pi minus pi by 3. Done. So sec 2 pi by 3. Okay. So sec y equal to minus 2. Then minus 2. That means sec, it is 60 degree. Sec 60 degree equal to 2. Now how to remove the minus sign? We know that sec pi minus theta equal to minus sec theta. So therefore minus sign can be changed with the help of sec pi minus pi by 3, sec 2 pi by 3. Most important is now, what is the range of the principal value branch for sec inverse? The range for principal value branch for sec inverse is 0 to pi, excluding what? Excluding pi by 2, right? This is the range of principal value branch for sec inverse. Therefore, 2 pi by 3 obviously lie between 0 to pi. So you can just write 2 pi by 3, and it's minus pi by 3. So which is the value of the given functions. We have done this. We're trying to write the answers directly. In exam, you try to write the answer directly, and where you have a problem in some questions, you can solve separately. But after lots of practice, it's obviously you can write the answers directly. Okay. With this, we'll wind up today's class. And thank you so much for attending this class. And I hope you will go through this and you will solve maximum number of questions based on in this topic. And next we'll discuss, already I said that we are going to discuss many more important questions as well as and the important properties. Okay, thank you so much for watching my video. Thank you.